So, picture this. You've literally spent months agonizing over this massive 200-page university thesis. You're finally done, you drag and drop it into a cloud folder, a little loading bar flashes for, a few seconds, and boom, it's magically available on all your devices. But have you ever wondered what actually happens in those few seconds? Well, in this explainer, we're going to unpack the underlying magic of secure cloud storage. We'll reveal the incredible, honestly, kind of mind-boggling architecture that works behind the scenes to keep your most important files safe. Okay, let's dive right into this. Because the reality here, it's not just a simple copy-paste to another computer somewhere. Not at all. During that tiny loading bar, a massive, entirely invisible security workflow is firing off. You're actually triggering this highly complex sequence of authentication, encryption, and data distribution. Here's our roadmap for this explainer. We're going to follow a single file's chronological journey, from the upload beginning to securing data in transit, protecting data at rest, managing sync and updates, asking who holds the keys, and finally, looking at the weakest link. All right, let's kick things off with part 1. The upload journey begins, specifically looking at how we verify identity. The very second you hit upload, the application first grabs some basic metadata, stuff like the file's name, its size, where it's located, and it does this while the file is still sitting completely untouched on your local computer. Because before accepting a single byte of data, the cloud service has to ask, hey, is this really you? It's exactly like a bank locker, right? I mean, before a bank even lets you step foot near the vault to open your locker, they check your ID. The cloud uses authentication to do the exact same thing. If you aren't properly logged in with an authenticated session, the upload just simply doesn't happen. Full stop. Moving right along to part 2, securing data in transit through the HTTPS pipeline. Because, let's face it, sending your hard work across the internet completely unprotected, absolutely terrible idea. It would literally be like passing your printed thesis around a crowded room where every single person can read every page before it gets to the professor. No way. So to prevent any eavesdropping, your device establishes a secure encrypted HTTPS connection with the cloud server. Think of this connection as a tightly sealed armored container. Everyone on the network, your internet provider, the guy next to you on the public airport Wi-Fi, they can see the container moving, sure, but they absolutely cannot see what's inside it. Your file is completely protected on the move. Now, what's really interesting here is how perfectly synchronized these early steps are. In just mere milliseconds, the file is prepped, your identity is verified, that secure armored channel is locked in, and only then does the actual data transfer kick off. But here's the kicker. Your file doesn't actually travel as one giant block. Nope. Large files are sliced up into much smaller pieces, which we call chunks. Imagine having to move an entire physical library across town. You wouldn't try to carry all the books at once, right? You'd pack them up and move them one box at a time. By uploading these chunks piece by piece, the whole process becomes incredibly efficient. If your internet suddenly drops out halfway through, you don't have to start from scratch. The cloud service intelligently resumes uploading the remaining pieces the second you're back online. Which brings us to part 3, protecting data at rest, once your files are actually inside the cloud. So when those chunks finally arrive at the server, a few things happen. They're scanned for corruption, storage space is allocated, and this is absolutely crucial, redundant copies are made. The cloud scatters your data across multiple storage systems, so if a physical hard drive fails somewhere, you don't lose your data permanently. But wait, they don't just store it as clean text for anyone to read. They use what's called encryption at rest. This acts just like a rented locker inside a highly secure storage facility. It is a massive layer of security. Because of encryption at rest, even if attackers literally broke into the data center and walked out with the physical storage drives, they wouldn't find your thesis. They just end up with a bunch of scrambled, totally unreadable data. And this just brilliantly highlights how the whole cryptographic ecosystem works together in total harmony. Authentication keeps the front door locked, secure communication acts as the armored truck on the highway, encryption at rest secures it in the warehouse vault, hash functions step in to verify that not a single byte was messed with along the way, and finally, access controls make sure only the right people can view or edit the file. It's a complete start-to-finish life cycle of protection. All right, part 4, seamless synchronization and updates, focusing on device syncing. You know that magical feeling, right? You open your phone minutes after an upload on your laptop, and boom, the exact same file is just sitting there waiting for you. Behind the scenes, your phone is acting as another authenticated device asking for access, and the cloud securely delivers that decrypted file down to your phone almost instantly. But what if you make an edit, Let's say you catch one single spelling mistake on page 150 of your thesis. The cloud doesn't waste time re-uploading the entire massive 200-page document. Instead, it only syncs the specific file chunks that actually changed. It's literally like mailing a single corrected page to the library instead of reprinting and shipping a whole new book. This smart syncing saves a huge amount of bandwidth and keeps all your devices perfectly updated in real time. Moving to part 5, who holds the keys? Let's talk about your actual privacy reality. So the crucial point here is we know your data is encrypted when stored, but to really grasp your privacy reality, we gotta ask, who actually holds the keys to those locks? This is a huge distinction in cloud security. With mainstream cloud services, you generally get provider-managed encryption. The provider uses their own dedicated key management systems to hold the encryption keys. Now, this is awesome for convenience. It lets you search your files, collaborate on documents with coworkers, and easily recover your account if you forget your password. But contrast that with true end-to-end encryption. With end-to-end, only you, the user, hold the decryption keys, nobody else. It's built for highly sensitive privacy, meaning literally not even the cloud provider themselves can read your files. Understanding which of these two setups you're using is absolutely essential for managing your digital privacy. And finally, part 6, the weakest link, looking at this whole system from the attacker's perspective. I want you to put on your hacker hat for a second and think like an attacker. You know for a fact that breaking modern cloud cryptography, cracking those armored HTTPS containers, or decrypting those highly secure storage drives is basically impossible. The math is just too strong. So if you can't break the math, where do you strike? You strike the user. The most common attack vectors out there have absolutely nothing to do with breaking encryption. We're talking about phishing pages meant to trick you into handing over your login, sneaky malware on your laptop, weak passwords, or just users accidentally creating public sharing links to confidential stuff. In real-world data breaches, the weakness isn't some complex encryption algorithm failing. It's almost always compromised accounts and poor security hygiene. Which really brings us to this powerful realization to close out our explainer. The cloud works absolute magic behind the scenes to authenticate, transmit, and protect your files with essentially military-grade precision. But at the end of the day, as the saying goes, cryptography protects the data. Users must protect access to the data. You are the ultimate guardian of your own security. So, I'll leave you with this. Are your passwords and your daily access habits anywhere near as strong as the cloud infrastructure protecting them?